I had a request to do number 94 in section 6.1 and wanted to go over that. It was too detailed to just send a written type of thing, and so I'll make a video and then share it with all. Here's the question: to take the tangent of cosine inverse of root 3 over 2 minus sine inverse of negative 3/5. And so there's a couple of things that I need. And so let me just write that out. Here's what we need. The first thing we need to know is what's the tangent of a minus b, right? We could look that up. Maybe we have it memorized. Remember, it's the tangent of a minus the tangent of b all over 1 plus, and then the product of the two. So I'm going to need to know that this is the process that I need to go through. Based upon seeing that, I'm going to need to know what the tangent of a is, and I need to know what the tangent of b is. Then I'm just plugging in some numbers. So remember what a is. Let me do some highlighting here. What's the best thing to highlight in? Let me grab a yellow. Let's focus on a. Tangent of a. This is a. Whatever. I don't actually need to know the angle, although you do know it. Cosine inverse of root 3 over 2 is pi over 6. You can totally do it that way. We're going to run into difficulty, though, with the negative 3/5 if we do the same thing. But that a and that a are the same thing. And so, and then b, and let me try this a different way, see if this is nicer. B is this b. That's nicer. So I'm going to come in here and I'm going to erase this guy and do it a little bit nicer in yellow. A big swoop and a big swoop. Okay, so that's what our A's and B's are like. So let's go work it out. So because I'm not going to be able to know a memorized angle for the second one, I'm just going to show both of them the same way. If I look at A, right, A's that yellow one. Let's see if I can write in yellow and if it stands out. Tangent of A, that yellow one. Well, if I go to find the tangent of A, what I do know is that A is a first quadrant angle because cosine inverse of a positive number would end up in the first quadrant. I know its adjacent side is root 3 and its hypotenuse is 2. And so I just need to figure out this other side. I need to figure out that y height because tangent's opposite over adjacent. And so let's go figure out that other side. We know 2 squared needs to be equal to y squared plus root 3 squared. Or 4 needs to be equal to y squared plus 3. Or y squared needs to be equal to 1. So y then would be equal to the square root of 1, or just 1. And so as I come in here, let me erase this y. We now know that that y is 1. And so what do we know tangent A is? Tangent A is 1 over root 3, or commonly written as root 3 over 3, right? Both are the same. Done. Now we could have gotten that recognizing that was pi over 6 and knew its tangent, right? So for some of you, like, that's a huge waste of time because you knew that angle. Okay. How about tan B? Let's look at that one in green. Tan B is related to this second angle that has sine of negative 3/5. So I'm going to go ahead and erase this work that's here in yellow that helped me figure out that the tangent of A is root 3 over 3. Now where is sine negative? Well, in 2 quadrants, right? But if I'm looking at sine inverse, it's got to be a very specific quadrant. It's got to be the 4th quadrant, right? Because it goes from minus pi over 4 to pi over 4. And so sine is opposite, right? Because this is B right here. Sine is opposite over hypotenuse. And so if I want to find that x, no problem. X squared plus negative 3 squared is equal to 5 squared. So x squared plus 9 is equal to 25. X squared is equal to 16. And then x is going to be the square root of 16 and the positive one because I'm moving off in the same direction. I'm sorry, in the positive x direction. So this x right here we just found out was 4. And so what's the tangent of B? Easy. Opposite over adjacent. Negative 3/4. Opposite over adjacent. Awesome. Okay, now we have everything that we need. Now what we need is arithmetic skills. So we use our trig skills first to understand that we have what we'll need in order to find the tangent of a minus b. We recognize that we can use triangles in order to figure that out. We're using our knowledge of the inverse functions by placing them in the right quadrants. So now what we have is just some patience going through in order to figure this out. So the tangent of cosine inverse of root 3 over 2 minus sine inverse of of negative 3/5 is simply this. Tangent of that first angle, which we know is root 3 over 3, minus the tangent of the second angle, which we know is negative 3/4, all over 1 plus tangent of the a, which we know is root 3 over 3, times tangent of b, which we now know is negative 3/4. And the rest is just arithmetic, right? So if we fall apart here, it's not our trig skills that are haunting us. It's some other skills. And so how do we want to do this? It's really up to you. Let me just clean some things up. This is root 3 over 3 plus 3/4. And on the bottom, 1 minus 3 root 3 over 12. If I clean that up a little bit, actually, let me step back a little bit. What I could have done, let me do this in red, is crossed out these 3's to make my work less. And so what we really get out of this one, you could see it there, it would have reduced. What we really get out of this one is root 3 over 4. And it's negative combined with that addition is what we have. So personally, what I would do is hit everybody by 12. Top and bottom by 12. The 12 would distribute across, and so I'll just go ahead and distribute. And look what we get. We go back to black. We get 4 root 3. Awesome. Plus 9. The 4 and the 12 cancel to produce a 3. 3 times 3 is 9. 3 times 12, 3 goes into 12 4 times. That's where those are coming from. I know you saw that, but just thought I would be really clear. Minus 3 root 3. Okay, they're not going to leave the bottom like that. They can't. It has a square root in the bottom. And so we know how to fix that, right? So as we go forward with this, and let me just flip and make sure that they're not going to just leave it like that. If I look at the 6.1 number 94 answer, yeah, they're not going to leave it like that. What are we going to do? We're going to rationalize the bottom. Where did we learn this? Algebra 1. Where was it reinforced? Algebra 2. That is why it's never being taught again. Now I can't cancel anything, or I would, but we're going to hit top and bottom by the conjugate. You knew to do that. If you didn't, take a look at your algebra books, and they'll show you. So let's take a look at what happens here. 4 root 3 times 12 is 48 root 3. 4 root 3 times 3 root 3 is 4 times 3, 12. Root 3 times root 3, 3. Run the 9 through. 9 times 12. What's 9 times 12? 108. Is that what that is? Let me just check. Don't trust myself. Yeah, 108. Okay. Plus 9 times 3 is 27 root 3's. Okay. And that's all over 12 times 12, which you know is 144. And then you know not to do any of the middle terms, so it's going to be minus 3 times 3 is 9. Root 3 times root 3 is 3. Okay. And so we end up with this mess. Well, let's clean it up. First of all, well, let's just clean it up. So we got 48 plus 27. And so we have 75 root 3's. 12 times 3, right, which we know is 36. And then we're going to add 108 to that and get 144. And that's all over 144 minus 27, or 117. Now I think everything's divisible by 3, so let's pull a 3 out of everybody. 75 divided by 3 is 25. 144 divided by 3 is 48, and 117 divided by 3 is 39. And so we get a nice 48 plus 25 root 3 all over 39. That's how they have it written in the back. In the back they have the 48 plus 25 root 3 all over 39. I flipped to the back in order to check that. My book has the answers in the back, not how to get there. But that's what you would do. Now, there's a huge reliance upon trig in the beginning, but if this is a hindrance to you to clear complex fractions, to rationalize denominators where there's two things in present, you really want to work on that and get better at that. So, great. This will help you in that regard.